Hi, I'm Jeff McKenzie from Jans, and we're here today to look at some of the features of Furman power conditioners. Now, Furman have been making power conditioners for quite some years. They're a well-known name in the industry, and they provide many benefits, including supply filtration to avoid noise contamination into your main supply for your sensitive audio, lighting or control equipment. But one of the features we want to look at today specifically is EVS, Extreme Voltage Shutdown. Now, the point of EVS is to protect your connected devices should a high mains voltage event occur. Now, you can often see products on the market that claim to give you this level of protection, often in sort of domestic power strips like these guys. Now, the way they work is they use a semiconductor component called an MOV, a metal oxide varistor, and it's trying to shunt any high voltage spikes around your connected equipment. And they do it moderately well. The problem with this approach, though, is that the MOV and your connected equipment are always in parallel online. So you're relying on the MOV shunting as much energy away as it can, but it can't disconnect your product. So it's always still online, it's always still going to be exposed to some degree. Additionally, the MOV itself will at some point, if it tries to absorb too much energy, explode. And then once it's out of circuit, it no longer protects your devices. So Furman have taken a completely different approach to this. They've got what they call their EVS, Extreme Voltage Shutdown circuitry, built into most of their professional products. And it's a relay that physically disconnects your product should it detect a high-level mains event coming in. And it acts very, very quickly. So to give you a quick demo today, we've got a Furman PL Plus CE here running this little light bulb here. This other light bulb is connected directly to the mains. So to simulate our mains high voltage event today, we're generating our own mains. We're using a Crown iTech 1200 with a 50 Hertz generator feeding signal into it, and then a step-up transformer so that we can adjust the mains voltage, well, our simulated mains voltage, anywhere between about 100 volts and 300 and something volts. So this light bulb here is running off the Furman PL Plus CE. This light bulb is running straight off the output. Our mains voltage is currently running at 234 volts. As I start to increase it, when we get to about 270, which is the cutoff point for EVS, you'll see the Furman disconnect this device from the line. This one will stay online. So we'll just start to bring the mains up now. We're at 247, 260, 279. You see that the Furman has instantly protected that light bulb. This one's being exposed to the full extent of the mains over voltage event. When this happens, as you can see, the Furman remains isolated to protect your equipment. And then eventually, once you've worked out what happened, you can come along and you can reset the device just by toggling the front panel switch. And then you're back online. Okay, so we've just connected up a couple of typical pieces of production electronics. In this case, we're using some old faithful Shure U-series wireless microreceivers. Now, before anyone yells, no, these ones were traded in recently as part of the 700 meg digital dividend program. So they're already destined for silicon heaven. So not a problem there. So what we're going to do is the unit on this side is connected via the Furman PL Plus CE. And the unit on this side we've connected via a domestic grade power strip which claims surge protection. And we'll race the two. We'll see how they perform. The one on this side, once the Furman detects a mains voltage of over about 270 volts, should disconnect from the line to isolate it. The one on this side, what will happen is the MOVs in this power strip will attempt to shunt that energy away, but it'll remain on. So let's just do the quick experiment. So we're currently at 247 volts. We'll wind the mains up. 260, 270. I heard the Furman relays click there, so it's isolated the one that's connected to it. 293, 300, 317 volts, 320, 336, 345 volts. You can hear the fans click in on the amplifier as it's attempting to protect itself. I've heard something pop just then. We've potentially destroyed something here. The power strip appears dead. I'll bring the mains back down into a safe region. And I can see some smoke coming out of the receiver there. So our domestic power strip, as you can see, has done pretty much nothing to protect the receiver in this instance. It's allowed the majority of that spike to continue across, and this has died. The unit that was connected to the Furman, if I now restore mains to sort of the normal range, 235 volts, cycle the power to the Furman, it reboots and we're good to go. So the product connected to the Furman survived that experience, just experienced a shutdown, but now that we're back online, we're good to continue. This one, it's all over, it's back to the workshop. It's also worth mentioning that this little guy here, the AC210, features all the exact same protection as its bigger brothers, just not in a rack mount format. So this guy is great for just throwing in the back of a rack or mounting behind plasma TVs, video displays, whatever, you know. I've even got a couple of these at home that I use just for protecting precious product at my place. So that's Furman Power Conditionings and the EVS Extreme Voltage Shutdown Protection in action. Thank you.